Okay, there's quite a few probability rules, so I'll just take them whatever order they appear in my head. Let's look at simple probabilities first, which means things that only involve one event. And then we'll look at complex ones, which are basically two or more events. Right, so if you're looking at a single probability, we know that the probability, I'll just put this in for completeness, the probability of A is essentially the number of ways A can happen. And then you divide it by the total number of things that could happen. So let's focus on cards because they've got lots of choices and lots of good things in that. If I said to you, what's the probability that you get a heart? Then according to this rule, there are 13 hearts out of 52 cards. The answer would simplify down to 1/4 or 0.25. Then you have a probability that you choose one card and it's a heart or it's red. So this is a probability when you see the word or. It's still one event, you're just taking one card out of a deck, but it's a heart or a red. Now it's all about how to count. There are 13 hearts in a deck. There are 26 red cards, right? 13 hearts, 13 diamonds. But the correct answer is not 29 out of 52. Because there's something else here, isn't there? Aren't they some cards I've counted twice? Right? I've double dipped. So 13 red plus, well, 13 hearts plus 26 red. Who have I double dipped?
Have you double dipped the hearts?
All of them. Agreed. So in this case, 13 out of 26 take away. The answer is 26 out of 52. Try a different one then. What's the probability that I get a heart or a king? Well, it's the probability of a heart, add the probability of a king, take away the probability of both. So that's the generic version of that. So I have 13 hearts, I have 4 kings. Oops, 4 kings. How many of those are hearts and kings at the same time?
One.
So I've only double dipped once. So that one ends up being 16 out of 52. So when you are doing or, and this is its generic form now, A or B, right? So you're taking one card out of a deck. What's the probability it's an A or a B? It's the probability of A plus the probability of B, take away the probability of both. It looks like this over 52, but if you separate them out, aren't each one of them over 52? So this is the more generic version. So that's the OR probability rule. Then you have the A and B. And the key word here is and. So for instance, what's the probability that it's red and it's a king. You could probably just replace that with the word both. What's the chances that it's both red, it's a red king? Well, there's 52, and of all the kings, only 2 of them are red. Oops. There we go, 26. And that's the rule for and is easy. What's the probability that you get both things? There's a guy, AC. Didn't see it often, but it is there. Do you know what AC stands for? What's the C stand for?
The complement.
Complement. So AC is just a very fancy way of saying not A. So in English, you would probably say, what's the probability that it's not A? That's essentially what that means. So if I said to you, what's the probability of it not being a king? You could simply just add all the cards up that aren't kings. And you'll have to trust me, there's 48 of those. But couldn't you also say it's 1 take away the probability that it is a king? And that's actually a little bit less work. So the probability that it's not a king, that's what AC is. And so what does it look like as the formula for a rule? It's 1 take away the probability of A. Now we use that rule a lot without even knowing it. Do you know if I tell you the probability that it rains tomorrow is 0.7, then isn't the probability that it's dry 0.3? Right, the complement, the opposite event. Are we cool with those? So there's and, there's or, and there's complement. And that's a single event rule. And then we have the complex event rule. Right, when you do 2 or more things, we'll stick to cards because I like cards, are easy to see. So in this story, you're going to choose 2 cards. And you imagine that you deal them 1 card on the deck, give them a shuffle, 2nd card on the deck. So you make a probability like this. What's the probability that they're both kings? You could phrase it, what's the probability of getting a king and a king? You could even phrase it as the first one's a king and the second one's a king. They are all the same events, they're just phrased differently. I'm sure there's a couple of other English versions of that I could come up with if I spent some time. So I want you to imagine you got a deck of cards and you give them a good shuffle and you turn the first one over and it's a king, right? And then you turn the next one over and guess what? It's a king. Well, I'll do the king-king version because it's less writing. It's a probability that the first one's a king times the probability that the second one's a king. But we are going to use an idea called conditional probabilities. In a normal 52 deck of cards, how many kings are there in it?
4.
4. Now the conditional probability. When we say the second one is a king, aren't we assuming that the first one is already has to be a king? So we've used up a king. So
now
there's
it's
only
1
3.
out of 50, 3 out of 51, right?
Right. So you remember those questions where it kept on changing every time, right? That's an example of it. Now that's some horrible decimal, and you know, you get it in your own time, and you know, write it down to 4 decimal places or whatever the homework asks you to do. Now you can continue this to what's the probability that I got 3 kings? Well, won't that be the first king? There's 4 out of 52. The next card is 3 out of 51. And the next card is 2 out of 50. And if you did that, it'd be even smaller answer, right? And that isn't unreasonable. Can you imagine if you were playing poker and you were dealt 3 kings? That doesn't happen every game, right? That's a very rare event. So its probability is very small because it's so rare.
Professor?
Yes.
So let's say if I want to say, what's the odds of pulling both red kings?
Okay then. So red king, right? Right. There are 52 cards. How many of them are red kings?
2.
Now, the first card has gone by, but didn't the first card have to be a red king? So there are only 51 cards left in the deck. How many of them are red kings?
1.
There's your probability. You see how that works?
Yep.
Right. Now, side issue. Conditional probabilities are being used here, but you can also do them with a single event, and it has a kind of notation that looks like this. What's the probability that you get a king given that it was a red card? So that funny vertical line is very often the word given. And we call these conditional probabilities. That's what was happening here. Well, if you are told that it's a red card, or whatever you happen to be told, that changes the bottom number. Because what that means is, it's not any 52 cards now. It's only red cards, because we've been given that that's what happened. And so can you see in this particular story, it changes to 26. Now, how many of the red cards are kings?
2.
So can you see that this probability is 1 out of 13? Suppose we do the dice one. What's the probability that you get a total of 10 given one of the dice was a 6? Whoa. Now, I'm not going to do the entire table, but remember that big table with all the things that could happen if you threw 2 dice? Right, so you throw in 2 dice. There was a 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. I guess I need another row now. 6, 6. Then going this way, you got 6, 1, 6, 2, 6, 3, 6, 4, 6, 5. Don't know if you can see that mess. But these are the only situations where one of the dice was a 6. And that one happens to be both are a 6, but it still counts, right? One of them is still a 6. The bottom number then is 11. If you count these up, there's 11 different things. And out of these 11, isn't the 6 and 4 and the 4 and the 6 the only 2 that add up to 10? And so the probability that you get a total of 10, given that one of the dice was a 6, is 2 out of 11 chances. So that's a different example of a conditional probability. Are we good?
That was great. Thank you.
You're welcome. Okay, what's our next? I wrote a little note down so I could go checking it, and I want to make sure I haven't thrown it away. What was it I was meant to look up for someone? Oh, I've got it here. Button, practice the others. Right, did anybody go in and check whether they can now look at their midterm and see their answers?
I can look at my midterm and see the answers.
Okay. If I get 2 people saying it, then I'm
I
good.
can as well.
Okay, we fixed whatever it was. It just needed some more tabs to be put on.
If you got one wrong, are you supposed to be able to see the correct answer? Because I can't see the correct answer. I can see that I got it wrong, and I can see like what I put down, but I don't see the correct answer.
Oh, Solomon, you said you've seen it. Do you see the right answer, or you just see your working? Or your answer?
One moment.
I don't see the correct answer.
Bethan, you can or can't?
I can, but at the top where it says like request extension, you can press C keys. So you'll have to press that to get the key.
Oh, okay. So there's another thing that you have to do as a student to make the answers appear.
Yeah, it's right above question 1. It'll say the due date for this assignment has passed, and you can click request extension or see the key.
Okay.
Yeah, I can see my answers now.
Okay, so you all remember that. If you forget that, this video is going to be online, so you can go back and listen to Bethany's description, so you can find the key that she is talking about. It's a little checkbox, I think, isn't it? And you hit it, and a little check mark goes on it, and then you can, you'll be able to see key. Is there a one up there that says see solution as well?
Not that I'm seeing.
Okay, so at least you can see the key and you can see your own answer. That's maybe as far as it'll go.
Yeah, there's just a little red button at the top for view.
Okay. We're good. Next topic. Anything? It's open-ended. Tell me what you want. You're even allowed to mump and groan. So if you want to get some frustration out here, because I think complaining is good for the soul. So if you've got that in your system and you want to get it out, go for it. I'm big enough I can handle it. Have any of you been frustrated by the idiosyncrasies of WebAssign, that sometimes you do everything right-ish, and it's just this little quirky, oh, you wanted 2 decimal places, not 3, and you get caught. Does that frustrate you at times?
It's actually not as bad as some of the other programs I've used, so.
Okay. So
I like it too.
Yeah, because like if you do extra decimals, it will still mark you right. At least for me, like sometimes I don't round it, it will still mark you right. So that's nice.
Okay, so it's a little bit more flexible.
Yeah.
So that's good. So when you say you've seen other programs, does that just mean you've done other things on WebAssign, or just totally
No,
different programs?
like other math programs online.
Okay. So
Like
it's not the
Alex-
worst in the world.
Yeah, it's not the worst at all.
Okay, that's good. Any other questions? Because I mean, your time is very valuable, so I want to make sure that I use your time wisely.
I get stressed when the p-value, all the answers are correct, but for whatever reason in SALT, the p-value, sometimes it works and sometimes it doesn't work.
Oh God.
That's actually, yeah, that's a problem I face as well.
For me
Yeah, that is. Well, I'll tell you what the workarounds will be. When you're doing your final exam, for instance, I know that SALT does most of the number crunching for you, but doesn't SALT tell you the p-value? And then you have, but you don't use it as a number, you actually have intervals and you pick the right interval. So if your problem that you've got the right p-value, but it doesn't match the interval that they say it's in, or you've got
No,
the
the
wrong,
one-
a different p-value.
The one that I have a hard time with is SALT will say your p-value, and you have to type it in because it has the box, and they want it rounded to four decimal places.
Right?
And I can do it 500 different ways, and then I finally pull out my calculator, and it's nowhere close to the right answer. But everything else that SALT provides is correct with the data that I inputted.
So it does all the other stuff. It does the confidence interval, right? It does whatever else it does with the p-value. It just doesn't do the p-value. That sounds weird. I don't know. I can't think. My brain has no. I don't know how to work around that. Is it? It just does it when it feels like it, or it's consistently does it?
I had it happen twice on 8.5. I think homework 8.5.
There is a possibility that you're doing a not equal to one, in which case you have to remember to double the p-value. But SALT should do that automatically. Could it be that?
Like I've tried doubling it and then
And halving it.
Yes, and then I go in and I put everything correctly into the calculator, and it just gives me a number that is much different than what SALT provided. So I've just been double checking all my answers on the p-value on the calculator. So after we do the exam, because I don't remember the midterm, does it tell you that like which one was wrong?
Yes. Yeah, in your midterm, you'll go back. When you look at your midterm, it should have a little check mark or a little red cross
But
for the right and the wrongs.
My worry is during the
won't.
final, when we're using SALT, if the p-value is not correct because of a SALT error, how do we know?
You won't, but I will, because you've now told me to be in the lookout for that. So every question that involves a p-value, I will be extra careful about checking. What would make my life much easier is that if you put down in your working what your p-value was, and the reason I want to say that is that if it's a box and you type it in, that's fine. But isn't a lot of the cases it's an interval that you choose? The p-values between 0.1 and 0.2 and so on. If you only do that check box thing, and SALT did something wrong and it's in the third answer, not the second, I won't really have anything to work on. But if you write down in your working p equals nothing 0.123, then I'll know what your p-value is, and I'll be able to work it that you did it correct and SALT was just being SALT. That's probably the best I can say. Hopefully it's not something that happens too much. Although now that you say that, it did happen that I had a really bad day once where I couldn't make anything work. And I had to wait until my next class where I did exactly the same thing and it all worked fine. I even put a video on saying, these are the correct answers to, it was in chapter 8 somewhere. So I know what happens. Maybe SALT has bad days. Maybe that's it. It just does bad days. Do we have any other questions?
Can we do an example of the p-value one just to find it, just a refresher?
Sure. There's a lot of different kinds of p-value ones. There's proportion ones. There's ones with means. Is there any particular one you want us to do? You want me to do? Because they happen in a lot of hypothesis test questions have p-values, but there's single and difference between two in proportions and in means. So basically there's 4 combinations out there. Which one do you want?
Either one. I don't have a preference really.
Okay, let's do a single proportion because they're a bit easier to do by hand. Oh, wait a minute. I can just use SALT and make up my own question. That way I don't need to do it by hand. And then I can show you it by hand after I do it to do the comparison, right? So if you hold on a second, I will load up 8.3 hypothesis test with one proportion. Okay, and pay no attention to the question that I'm going to use. I'm just using it as a salt, so I can use salt. So I'll make up my own question here. How many people do we have in this class right now? 5, 10, 15, 20, 25.
37.
Thank you. Okay, so in this story, we're going to take a sample of 37 people, and I'm going to ask you something. So n equals 37. I think the book, or the textbook, sometimes calls the responses little r, so the people who said yes. Right, so question. Darn, it's hard to think of a question just at the spur of the moment. How many of you have four-legged pets? So cat, dog, lizard, it got to have 4 legs to count. So stick your thumb up and I'll do some thumb counting. Hold on a second. I haven't got the full screen. Why can't I get the full screen? I can't do the full screen while I'm sharing the blinking whiteboard. Okay, I got go 1, 2, 3, 4, 5, 6. Good grief. 3, 4, 5, 6, 7, 8, 9, 10. Kick over, second page, 11. We're calling it 13. It might not be exactly 13, but it's some value very close to that. So 13 out of 37, right? So here we go. And we want to say test. Is there enough evidence that less than 50% have four-legged pets? Now that should work out. In our sample, p hat then is 13 out of 37. And 13 divided by 37 is, and I'll do it to 2 decimal places, is 35%. So in our sample, 35% of you have pets, and we're saying, is there enough evidence based on this sample to show that less than 50% have four-legged pets? So we'll set up the null and the alternate. Now, when it's a single proportion, isn't the null p equal to whatever this is as a decimal? And isn't the alternate whatever this says? So is there enough evidence to show that less than 50%? So that would become less than 0.5. Are we comfortable about that piece of the puzzle? Right, we've done enough of those. Now, you should have, as part of the question, at a significance level of, let's say 5%, right? So salt's going to take over now. I'm going to use salt. And the one that you choose is inferential statistics. We're going to choose a one sample proportion. The number of successes in our story was, there were 13 people. And that was out of a total of what, 37 people?
We can't see salt.
You can't see salt. Darn it in space.
No.
Can you see salt now? Can you see the page after salt? Okay,
Yes.
right. I'm trying to find where I got it from so I can click on it again. Can you trust me that I hit salt button, right? Any salt button will do. And then I chose one sample proportion, typed in 13 out of 37, and we're looking for less than. And I've already complained about it, but I'm going to complain again. Wouldn't it be much easier if they swapped these two around for you to see what the heck was going on? Because in the English language, you would probably say less than 0.5, not 0.5 less than. It just clunky. And then I should hit simply generate results. And can you see the p-value here? So the p-value that we've got from salt is pretty straightforward. 0.035273, right? So far, so good. Right. Now I'm going to leave that and return to the paper because it's more useful to do it this way, right? So we've got this fella here. And we have our p-value. And we do our test. Is the p-value less than alpha? Is 0.035, I'll round it off, less than 0.05? And the answer here is yes. So imagine this is what I would probably be seeing as working. I wouldn't see any of that, right? But I'd probably see this bit here, right? So I know that you were using the right numbers in the right place. I'd definitely see this, although you might tag that as a choice. I definitely see this, whether it's 2, 3, or 4. I definitely see you writing this line down because this is telling me I know how to do a hypothesis test. This is the hypothesis test part. This is where you're testing, right? Is this less than that? And a little yes, because it is. Now, when this is true, haven't we now enough evidence to show that less than 50% of whatever the population was meant to be in this story, less than 50% of you have four-legged friends? Are we good?
If the sign is either way, isn't usually
Right, let me ask you to either speak louder or something because I can't really understand you. Sorry, Brittany.
so if the sign was insignificant, or I mean, yeah.
If this was a no, right?
Yeah, would it be the that usually goes with the either way, right?
No, it can go with any of the three possibilities. There are 3 hypothesis tests. They look like this. And I'll just put in some example with the numbers. And they even have names associated with them. Right. The one we've just did is it less than 0.5? And that's called a left tail test. You could have it's equal to, I don't know, 0.75, a different story. And the one that you're looking for evidence is the either way, which is it's not the same as, right? It's different from various phrasing, right? And that's called a two-tailed test. And the third possibility, a different story, let's say 0.9, And we are trying to see if there's evidence that it's even bigger than 0.9. And that's called a right tail test. Now, in every single one of them situations, it's still p-value less than alpha, right?
Mhm.
The test in every one of these is still the p-value less than alpha. And it's just as likely to be yes, it is, as it is to be no, it's not, right? So there is no, you know, this tends to be one and this tends to be the other. No, each one of them is just as likely to be yes, it is true or no, it's not true. And when it is, don't you have some jargon sentences that you just have to get used to in the textbook? With a significance level of 0.5, we reject the null hypothesis. And I can't quite remember the phrasing, but essentially there's significant evidence for HA.
So for
And
the
you
two-tailed, how do you tell which?
Same test. The p-value for a two-tailed is the same. You know, the SALT will tell you the p-value. And so you just take whatever that number is and still compare it against the significance level 0.05. Right. So now if you're doing it by hand, that's different. If you're doing it by hand, when it's a two-tailed, you double the value of p to accommodate the two-tailed part. That's only what you do if you're doing it by hand.
Okay.
Do you want to see this same question by hand, just so you can get an idea of how this number would come about? Yes, no, maybe. What do you want?
Yeah.
Yeah,
I
it doesn't
would.
sound like you would. Okay. Same data. We are going to get the p-value. Oops, sorry. We're going to get the z-score first. P-value comes second. And it's that guy in the bottom is your standard error. Can you remember what the top guy is? There's a formula for it. Essentially, data, take away the mean. Right. So in this case, 0.35, take away 0.5. So I should do the whole calculation. So it's a 0.35, take away a 0.05, divided by the square root. And notice that the p is this guy. So this one happens to be p. They sometimes call that q, which is the same thing. It's 1 minus p is q. And in this case, we got a 37. That's a very messy looking calculation, but with a bit of luck, I should be able to do it without screwing up. So put a bracket around it, 0.35, take away 0.05, close the brackets, divided by a big ugly square root, 0.5 times 0.5, and divided by 37, close the brackets, and that's not right. And it's not right because what did I type in wrong? Isn't it 0.5, not 0.05? So, yeah. So let me fix that. And this is going to be the correct answer. It should be negative, which it is, and it's negative 1.824. Sometimes they ask you in the questions for the Z value. If they did, that's it. But SALT gives you it anyway, so it's not a big deal, right? Now the value I've got here is a little bit different from the answer that SALT gave, and that's because I rounded off to 2 decimal places. If I used the entire you know, 6 decimal place number here, I would have got their answer as well. So continuing with this, what we have now is p-value. It's a probability that you get a z-score less than this guy. Now, I got this p-value here. I'm not going to get the same guy. I'm just going to get some dead close to him, right? And that's because I've rounded off. Now, does anybody know how to find the probability of a z-score less than this guy? Can you remember the funny looking guy? It starts with an N.
Normal CDF.
And the format for this one is -9, -1.824, 0 and 1. I think that's the right way around. Where is normal CDF hiding?
Under distribution,
So blue button variable to get distribution. Choice number 2. Some of you have a little menu. I have to do it the old fashioned way. -9, comma, -1.824, comma, 0, comma, 1, close the brackets. And I got the answer 0.03407 and 0.03527 was what SALT gave us. Can you see that there's a little bit of difference? But in the big scheme of things, 0.34 and 0.35 is probably not going to make a big difference, is it really? And as I said before, if I'd used that number in here, I would have got exactly the same answer. Okay, another question? Oh, before we continue, those people who couldn't make it, which are typically the Tuesday, Thursday people, and they still could get their 2%, but I told them in the email there's going to be a special like word that if they had to watch the video to get it. So here is that special word, tralfamadon.
Can you
Does
spell that,
anybody?
please?
Well, you don't need to spell it because you're here. They just need to spell it so it's phonetic, and I know that they've done it because they'll probably say, I can't spell it, but I know you said it. Tralfamadon.
What language is that?
It's not a language, actually. It's from a science fiction movie. Slaughterhouse, I can't remember the number. I think it's Slaughterhouse 258 or 528. It's a really weird movie. It's a kind of cult movie for sci-fi people. A little group of people know it. So go looking for it. It's a very good movie, but it will hurt your head because do you know those movies that have flashbacks, you know, where they flash back to the past, you know, that happens in some movies. This movie has flashbacks, flash forwards everywhere. You do not know at any point in time in the movie where you are in time in relation to the story. It's quite weird, but very well done. So if you're interested,